Walk back and forth.
I don't know. Yeah, are you guys?
You're about the air.
Like, we're sorry. Trying to make sure like the pulse not. It's like, yeah. It's like that. Yeah. Are you?
Oh, yeah.
So it's just the engineering. So it's not just. I just have these squared out. That's why. Outlook thing. Yeah. So like launch it good, yeah, not. Then like. Oh my.
It's like singing like this. It's we got assess it.
No.
Oh, wait. Okay. Nobody's in here. Oh, it's.
You guys are excited.
Yeah, but just know that you can do it. So there for something. Yeah, I believe that's 3 years. I thought it was going to an hour. Yeah, that's the only one. All of good. Does the next I'll try like you're leaving. I don't know. Well, I might just. Why is it in him, huh? Well, I think. Was the time, right? I saw my first class was. If you have the. Yeah, I don't know about that because I like.
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today?
Good, I'm good.
Good. Yes, it's hot. Apparently the AC is not working so well, so I may die up here, but you know, as long as some finite elements gets learned today, that's a bit. All right, so my name is Professor Justin Tran, so I am the instructor here. So this class is EGME 410. So I've had this up for the last 10 minutes, and so if you're in the wrong class, you know, I've closed my eyes, no shame, you can run out of here. But you know, hopefully everyone is here for. So plan for today is I just have some introductory slides today. So we're going to introduce just what this class is all about. We will talk about the syllabus, and so we'll go over all the office hour policies, all the deliverables, all the grading policies, things like that. And we'll take a tour of the course website. We'll see what time it is after that. If it's, if there's a little bit of time, we'll probably start the first lecture a little bit. But if, we're close to the end, then, we'll go ahead. Okay. All right, so that's the plan for today. Does anyone have any burning questions to ask before we get started? Okay, all right, so let's go ahead and get rolling. Okay, so a little bit about myself. So my name is Professor Justin Tran. I just said that, but I'm just reading off the slide here. So my office is in the engineering building. So not this one, it's the one that's across the quad. Probably everyone here knows where engineering is. I'm on the second floor. So you take the elevator up to the second floor, you take the stairs, you just turn right. You go to the end of the hallway, you keep turning right, and then I'm in the corner. So the room is E220. So my email is justran@fullerton.edu. So you can see it's a combination of my name. Some of you have had me before, you probably tired of this joke, but it also looks like the email address of a running club here on campus. That's just how my name is. But I do prefer that you guys email me. That is kind of the primary way that you guys can reach out to me. Okay. So I grew up here. So I am from Cypress, California. So if you don't know where that is, that's about 10 miles west on the 91. So, I know Fullerton very well. I used to go to downtown Fullerton all the time with my friends when we were in college, and, did some things I can't repeat here, but it was a lot of fun. So I'm very familiar with this area, very familiar with Orange County. This is home to me. So being able to work here and teach here is a dream come true. I'm very much a California boy. And so, I've done all my schooling here in California, all the LA, San Diego, up to Stanford, everything in California. All of them in mechanical engineering as well. So, this is a field that I'm very good at. My research interests actually have a lot to do with this class. And so, I am interested in looking at how we can apply engineering tools to study biomedical problems, specifically, blood flow. So a lot of my research actually uses finite element methods to simulate blood in the human body. Okay? And also just as a person who's been teaching science, technology, engineering, math courses for the past 7.5 years, I'm just interested in how we can do this better. Okay, so STEM education is another area. Okay, learning objectives. And so, I know there's some familiar faces out there, so some of you may be familiar with this. But for those of you who have never had it before, I report these, or I use these learning objectives pretty. So today's a little bit of an exception just because today's the first day. But usually when you guys arrive here in class, usually I'll try to get here, maybe 10 minutes. I will post the learning objectives. Okay. And so you can think of the learning objectives, one way to think about them is you can think of them as just a simple outline in terms of what we're going to cover today. So I always recommend, you guys to write them down in your notes just as a way to organize your notes. But, if you'll notice, I write these learning objectives very intentionally. So every one of these learning objectives here starts with a verb. The reason for that is that, these learning objectives are a way for you guys to test your own knowledge or to assess your own understanding of what we cover. Okay. So for example, if you read the first learning objective that I have here, the first learning objective is to describe the use and utility of finite element analysis in engineering work. Okay. So by the time you leave this room today, you should be able to describe the use and utility of finite element analysis in engineering work. Okay. Someone can, corner you in the elevator and ask you to do that, and you should be able to. Okay. So it's just a good way for you guys to kind of self-assess, self-test your learning. Okay. So at the end of every lecture, if you go back to the learning objectives and you say, can I do this? then you say yes, and okay, that's a good part of the lecture that you could. But if you reach the end of the lecture and you go back to the learning objective, say, hey, I don't think I can. I don't think I can describe the steps involved in the finite element process. Then that's probably a good indication that you should go back to the lecture notes, go back to the lecture recording, maybe come to office hours and ask questions of hey. So I post these learning objectives every day. We have the learning objectives for the week as well. Definitely use these and write them down because they're great study tools. Okay. So with kind of the front matter out of the way, let's get into the content of the class. So EGME 410 is about finite element analysis, or as we like to say, FEA. Not that finite element analysis is hard to say; it's just that we love acronyms. Okay. So what is finite element analysis, and why is it important? Okay. So some of you may already come to this class with kind of a preconception in terms of what FEA is, and so I think for the most part, people think software. And so most people think of ANSYS, they may think of Abacus, they may think of SolidWorks simulation. So those are great applications of FEA, and we are going to be running somewhat in this class. But if you look at kind of the exact definition of FEA, it actually doesn't really have to do with a software. And in fact, it doesn't even have to do with engineering in general. And so finite element analysis is really a numerical technique for solving differential equations on arbitrary geometries, okay? Which probably is not what you're expecting at all. But the idea with finite element analysis is that it leverages the power of computers to perform calculations at speeds that are much higher than. Okay. Now, how do we connect that to our understanding of FEA? Well, it turns out that most engineering systems, it's physical behavior. So we're talking about structural mechanics, heat, thermal analysis, heat transfer, fluid mechanics. The behavior of such systems happen to be governed by differential equations. You think of heat transfer, right? So we have heat equation. Fluid mechanics, we have the Navier-Stokes equations. For structural mechanics, we have the equations of linear elasticity, right? All of these are differential equations. Normally, these equations are too difficult for us to solve by hand, unless we make some very gross simplifications, simple geometry. But reality is not so simple, right? So if you're designing a real engineering system, right, you're designing a car, right? Though the car is usually way too complex for you to work out the calculation. And so the idea is to use finite element analysis to perform these calculations so that you can view the. Okay. And so with finite element analysis, we kind of use these computers. It really allows for the design and analysis of engineering systems that have very complex geometries, very complex loading conditions that we wouldn't be able to, Okay. And so with that, when you talk about analysis in engineering, there's three different categories that I like to say. Okay. So the first category is what I like to think of as analytical analysis. It seems like an oxymoron, analytical analysis. But an analytical analysis is, what you kind of think of as like a pen and paper calculations. You think about all of your theory-based classes up until this point. So things like solid mechanics, things like fluid mechanics, heat transfer, statics, dynamics, right? All of those are analytical techniques. Okay, so the idea is that you have some governing equation that governs your engineering system, and you solve it by hand. Okay. So the benefit of an analytical analysis is that it's very cheap, right? Student labor is very cheap. Pens and papers are very cheap, right? And so that's much cheaper than any other type of analysis you can. Okay. But the downside to analytical is that you're very limited to very simple situations. Okay. You can't really do a pen and paper calculation of an entire car. Not that. The other type of analysis you can do in engineering is what I like to call experimental analysis. Okay. So let's say you're curious about how a new car is going to perform, right? The best way to do that, or best way to get that data, is to actually build a car and actually test it, right? There's no better way than to just observe what's happening. Okay. So you would run an experiment and you would get data. Okay. Now the nice thing about experiments is that whatever data that you get from the experiments, there's no disputing, okay? Because it actually happened, right? It's not like an AI thing. You know, you tested it, it happened, you reported it, and so you know, there's no one's going to argue with your experiment. The downside to experimental analysis is that it's very expensive. And so, you know, it's not the cheapest to set up an experiment. Not very, you know, it's very time consuming as well. Okay? Especially if you're doing destructive testing. And so if you're doing crash testing on a car, right, you know, Toyota doesn't exactly have a ton of money to throw at Camry prototypes where you just crash for fun, right? So if you're going to do an experimental analysis, you often have to be intentional, just because you can't often do a bunch. And so the last type of analysis that's out there, which is kind of where we're going to be in this class, is what I like to think of as computational. Okay. So computational actually shares a lot of similarities with analytical in the fact that, you know, we have governing equations, we have differential equations, and we aim to solve them. It's just that instead of solving them by hand, we're going to be using the computer to solve them. Okay. So computational, so finite elements obviously falls into this category. So we're going to be using a software like ANSYS to do these calculations. And so the idea is that by using computers, we kind of overcome a lot of the weaknesses or a lot of the shortcomings of analytics, where we can actually handle these complex scenarios, complex geometries, complex loadings, complex boundary conditions, because a computer will be able to do all this calculation. Okay. So it seems like magic, right? So it seems like computational kind of solves all our issues perfectly. But even as someone that's in computations, you know, it does have its limitations as well. The most glaring kind of weakness of computational is that it is very tricky to set up, and it can give you false positives, right? And so you can get a result from a computational analysis that you may think is good, but if you set it up incorrectly, you would find out that it's actually very. So that's why a class like this exists, right? And so that's why, you know, you can't just use ANSYS, you know, just out the box. Well, you can, but you know, you may just end up doing things incorrectly. So a big part of this class is, you know, how do we leverage these computational tools in order to get something useful for our engineering? Okay. So let's look at some examples, right? So some examples that, you know, maybe you can do by hand, and then, you know, something maybe similar that you would have to rely on computers. Okay. So here we have a very simple beam analysis, and so we have a very simply supported beam. Right, so we have a beam that is loaded, has a pin support on the left, has a roller support on the right. We have a vertical load that's being distributed on the top, right? So this is something that you can solve by hand, right? And so there are equations, the Bernoulli beam equation that you can solve for the deformation of this beam. Okay. But if you were to do something more complex, right? Maybe something like you're designing a huge building or a huge parking structure, okay? So technically, you know, these types of structures, they consist of beams, right? And so you would think that, you know, I can apply the same beam equations to a structure like this, but, you know, once you start to add this, you know, huge amount of geometric complexity, you know, something like this just is not feasible to do by hand. So you would have to rely on computational tools to do it. Okay. So you can see here, you know, same equations, you know, same applications, just that the complexity is too much for you to do by hand. And so we have to rely on computers in order to do this for us. And so, you know, that analysis, so, you know, that trend is not just limited to structures as well. Okay. So let's look at a heat transfer situation. So I know, you know, some of you may have taken heat transfer already. Some of you may be taking it next semester. But, you know, something like this is a very classical problem that you can solve in heat transfer. So you have a slab of material here, right? So you have a rectangular block. It has a thermal conductivity K. Right, the left side is held at a high temperature T1, the right side is held at a low temperature T2. You can solve for the temperature distribution throughout this solve. So this is a very simple case, very simple geometry, very simple conditions. You can solve the heat equation in this situation. Okay. But as soon as you start to introduce some complexity, so you can see here, this is a turbine blade. It's being exposed to hot air, and so you can see here that, you know, we have temperatures that vary very wildly, right? So something like this, you know, technically not impossible, but very infeasible to do by hand. Okay. So, you know, here we've introduced kind of complex geometries, complex, you know, boundary conditions. So this is something that you would need software, you would need finite elements. All right, and then one last example with fluid mechanics. Right? So, you know, this is a situation that you could solve by hand, and so we have simple flow in a pipe. This is your Hagen-Poiseuille flow. So you would solve your Navier-Stokes equations. You could apply enough assumptions to simplify Navier-Stokes to solve this. Okay. But if you were to do something more complex, like say, this is a screenshot from my own research. So you can see here we have blood flow in someone's body. Okay. We have two vessels here. So this is a person's pulmonary arteries. This is their aorta. Right. And so to solve for the blood flow, when you have this geometric complexity, you would need software to do this. Okay. So that's kind of the theme of this class, is that finite elements, it's not magic. The whole idea with finite elements is to allow you to do the types of analysis that you would normally want to do by hand. It's just that the geometry or conditions or the loading is just too complex for you to do, so you let the computer do it. Okay? But your mindset is still the same, kind of what you are aiming to get is still the same. You're still doing engineering. Finite elements is just a tool to kind of help you get. Okay. Any questions on this so far? Okay. Good. Okay. I'll skip that for now, just because I know. Okay. All right. So, what is the process to actually running a finite element simulation? So we'll be going through this process. So I think probably not, definitely not today, but probably next Tuesday we'll do our first activity in ANSYS. And so there is a certain process that you're going to go through. Okay. So when we do our first ANSYS activity, I'll walk you guys through these steps, but I think it's good just on the first day to know what the general steps to a finite element are. Okay. So the first step in your finite element process is to define your geometry. So I get this question a lot for this class in terms of, how does this class connect to your SolidWorks course? So I think probably when all of you guys took it, we've changed the number, it's now 312. Okay. So finite elements is actually something you typically do after SolidWorks. Okay. So after you've kind of taken the time to design a part, come up with a solid model for the part, a 3D model, a CAD file, right? Usually the next question that you want to ask is, how is this part going to behave in practice, right? And so to do that, you need to run a simulation. But the first step before you can do that is to define what your geometry is. Okay. So a lot of times this involves, taking your SolidWorks file, importing it into ANSYS. That's how we're going to be using ANSYS for the most part. Sometimes we may draw our own geometry. So that's actually what ANSYS 1. But before you even get started in finite elements, you have to establish your geometry. Okay. Just because that kind of forms the domain, that kind of forms the subject for your simulation. Okay, next step is to specify your material properties. Okay, so eventually what we're going to be doing to your part is we're going to be virtually applying things like forces, things like pressures, things like constraints onto them. And so, we need to know how your part is going to respond to such forces and such load. Okay, so a big part of that is to specify what material your geometry is made out of. Right, so whether your part is made of aluminum or whether it's made of copper, or maybe it's made of plastic, right? That's going to affect its response, right? And so there is, an important step, and most people miss this just because it's, it's very easy to miss in ANSYS, but you need to specify your material properties to make sure that you're signing it correctly. Okay. All right, so some properties that we're going to apply are things like Young's modulus, things like density, things like Poisson's ratio. These are all parameters that hopefully you guys in these classes, right? So you're going to see how they apply and how they affect our finite. Okay, next is the discretization step. So I think this is probably the most famous part of finite elements, part that everyone probably looks at. And so the next step is to come up with a mesh. Okay, so a mesh is basically a breakdown of your geometry into much simpler shapes. Okay, so in reality, if you have a complex geometry, even for a computer, even an arbitrary geometry is too complex for them to solve. And so in order for a computer to actually do the calculations, it needs to actually break down your geometry into some shapes. Okay. So you can see here we have like a flange, like a fitting here. Okay. This flange by itself is too complex to analyze, but what we've done is we've applied a mesh and we've broken it down into all these little rectangular kind of prisms. Okay. It almost kind of looks like we've taken our geometry and turned it into Legos. Okay. That's what I kind of like. So this step is called meshing. Right? It's probably the most important step in the finite element process. We're going to spend a lot of time talking about meshing. Okay. And the whole idea is that, after you mesh your geometry, then what the computer is going to do is going to solve the equations on each of these elements individually. Okay. And by the way, this is where finite elements gets its name, because after you mesh, you get all these individual shapes here, which we call elements. Okay, next step here is to apply what's called the boundary conditions, right? So now that we have our geometry, we know what it's made out of, we've applied our mesh. Next step is to apply our forces, right? And so we need to apply any external forces, any external constraints that are going to be affecting our part so that we can run our simulation. And so this is the part where you kind of have to think about, what are the forces and pressures and effects that are going to be affecting our geometry, and make sure to apply those to virtually. Okay. Next step is what's known as the assembly step. And so this step here, when we're using ANSYS, is not something that you're going to see explicitly, because this is something mostly the computer handles. But in the second half of the course, we are going to be going over finite element theory. And so you'll see kind of what the step is all about. So basically, the idea with finite elements is that, when you take your system and when you solve the equations, you are essentially solving a large system of linear. And so the assembly step is basically assembling all these equations into one. Okay. And the reason we do this, right, and the reason finite elements work so well, and the reason a lot of computer algorithms work the way they do, is that computers are really good at solving linear algebra. And so there's whole fields of science where, if you can take a problem, if you can turn it into a linear algebra problem, then, you can probably form a company out of it and make millions of dollars. That's how AI works. So AI basically takes, its, problems, turns it into a linear algebra problem, a very, very large linear algebra problem, and then uses computers to solve those problems. Okay. Next step is the solution step. And so again, this is something that the computer is going to handle, right? And so this is not something that you're going to do by hand. The whole point of finite elements is to have a computer do the heavy calculations. Okay. But this is a step, right? This is a step that we have to acknowledge. And then finally, the last step in the finite element process is the post processing. Okay. So once the solution is obtained, that's when you can kind of go and start to do the analysis. You can look at things like the deformation. You can look at things like equivalent stress in the part, right? And so you can see if the part's going to fail. You can compute things like factor of safety, right? So that's kind of what's being shown here. Okay. And so you can use the results of your finite element analysis to do your engineering design. Okay. So for instance, for this image right here, right? Looking at factor of safety, we can see that all the areas here that are highlighted in blue have a very low factor of safety. So it's almost zero. Okay. So this kind of gives us an indication for, maybe if we're designing this part, maybe we add some extra thickness here. So maybe we add some extra material to increase that strength to make sure that it doesn't fade. Okay. So this is kind of the power of finite elements, to kind of highlight things in your design in order to, maybe drive your design in a way where you wouldn't be able to look at by hand. Okay. All right, so that's just kind of a very quick overview of the finite element process. Again, we're going to go through this together when we do our first activity on Tuesday, but I at least wanted to go through the process. Any questions on this so far? Okay. All right, so ANSYS is going to be a big part of this class. And so, make no mistake. And so, the question I always get when I teach is like, when are we doing ANSYS? When are we doing ANSYS? We're going to get to ANSYS, don't worry. But, another big part of this class is the background knowledge. Right? So, a class like this, when you're learning it in a university setting is more than just, learning how to click the buttons in the software, right? So you need to also kind of understand exactly kind of what you're doing. And so a big part of that is actually learning the theory. And, what I always remind people is that, finite elements is a powerful tool, right? There's no doubt about it. And as computers get more and more powerful, finite elements is going to play a bigger and bigger role. Okay? But at the end of the day, it is just a tool, right? It's not magic. It's not Jesus, right? There's limitations to a tool, right? Just like a hammer, right? And so, a hammer, it's a very useful tool in engineering, but just like any tool, it has its use cases, it has limitations. Okay? So what I want to kind of highlight to you guys, and what I want you guys to really understand, is that finite elements is really just a tool for you guys to use. Okay? It's not a cure-all for everything, and just as important as it is to learn how to use the software, it's probably even more important to know what its limitations are. right? And what types of problems it can and not be applied to, and when to question the result. That's what I want you guys to learn. Okay. And the idea is that this is really kind of the only class that we have for finite elements, at least at the undergrad. So when you guys leave this class, I want you guys to be able to put on your resumes that you are skilled in finite elements. Right? And so you're going to be experts, right? And so if you're advertising a skill on your resume, that's kind of the assumption, is that you're going to be an expert at that. And so if you put it on your resume, a company can hire you and ask you to do that from day one. And so as experts in something like finite elements, it's part of your responsibility to know, what the limitations are. Right? Because, when you get to the real world, and I've been in this situation before, you may be asked to do certain types of simulations, you may be asked to get certain types of data, right? And so you have to be the one to say, I don't think that's possible with the tools that. Because if you say yes and you produce bad data, then that's on you to, that's your profession, that's your professional reputation. And so, a big reason why we learn the background knowledge, why we learn concepts, is so that you know what. Okay, so let me give you an example. And so, if you think about what a vet has to do, right? And so on the one hand, a vet is expected to know what I call procedural skills, right? So a vet is expected to know how to give a shot to an animal, how to take maybe a blood sample, maybe how to perform eye and ear checks, right? And so those are mechanical skills that they're expected. Okay. But we also expect our vet, who is an expert in animal health, to be able to have conceptual knowledge as well. Right? So they should know why they're giving medicines to our pets, right? So they should not just be, this pill is blue. I think it's we should know, we should be able to trust our vet to say, if the vet recommends that they give this medicine, then that's something that they actually know that they have. Okay? They should be able to interpret animal behavior and to tell you why your animal is sick. Okay. So it's the same with finite elements, and so it's more than just pushing buttons in the software. You have to know when and why you kind of do it. Okay. And so, like I mentioned, ANSYS is going to be a big part of this class. So that is the finite elements software of choice. But it's not the only finite element software that's out there. In fact, there's many more out there. Right? So ANSYS is actually a commercial software. And so actually, if you want the full package of ANSYS, you have to pay a lot of money. Well, not you, your company has to pay money for it. Right? And so why do we choose ANSYS? Right? And so if it's a commercial software, it's kind of limiting. There are free finite element softwares out there. Why do we choose ANSYS? Well, I'll be real with you guys. The real reason is because ANSYS provides a free student version, so you can download it. That's a big benefit. Also, it's brilliant marketing, by the way. So by doing that, then they kind of ensure that all the university classrooms are using ANSYS. And so by the time you get to your companies, you can tell your employers, hey, we need to buy ANSYS, and then the companies pay ANSYS to do brilliant marketing. But it's very convenient for the classroom. Okay? But what we're going to learn in this class is not specific to just ANSYS, right? And so that finite element process that we just went over, all the concepts that we're going to learn in this class, that can be transportable to any finite element software that you use, okay? Because every finite element software you're going to be meshing, every finite element software you're going to be applying boundary conditions. The process is the same. It's just the only thing that's different. Okay? But with that said, ANSYS is very common, right? And so if you put ANSYS on your resume, then okay. So that's why we kind of focus just on ANSYS. But just know that ANSYS is not the only software that's out. Okay. SolidWorks is even trying to break into the finite element. SolidWorks has their own kind of simulation package, although people have very strong opinions on SolidWorks. But the one that we're going to do is ANSYS, just because it's pretty established. There's a free version. It's a good one to know. Okay. And then, just to kind of drive this point home. And so, one thing we're going to go over at the semester is, how do we verify and interpret our results? Just because ANSYS kind of gave you a result doesn't mean that it's automatic. Okay? In fact, I think what you'll find is that, a lot of times when ANSYS gives you a result, if you set it up incorrectly, your answer may be completely. Okay? So it's important to know, not only to kind of look at your result, interpret them, verify them, validate them just to make sure that they are actually correct and they actually make sense. Okay. All right, so that's just a very kind of quick introduction to the course in terms of what to expect, right? So we're going to be doing a lot of answers in this course, and so don't worry. You'll be able to apply answers to your senior design project as well that semester. But a big part of this class is going to be the theory. It's going to be the concepts, because all of that is important to use in everything. Any questions on this stuff before we get in? Okay. All right, so let's talk about the syllabus. Okay, so normally I print out the syllabus for you guys to have, but there are literally 50 of you. And so, if I print out the syllabus, it would eat into my printing budget and I need my print semester. So I apologize. So it'll be on Canvas for you to see, but we're gonna go over everything. Okay, office hours. So office hours are going to be in my office, and so that's E220. So that's in the other building, and so not this one here. It's on the other side of the quad. It's on the second floor. Okay. So my office hour times are listed here. So they are Monday, Wednesday, 5:30 to 6:30. So that's actually the same time as this class. And so I know a lot of you may have other technical electives at that time. But I also have office hours on Thursdays as well, too. Okay. So office hours, if you're ever confused about anything in the course, and so let's say that you're struggling with an ANSYS activity or you're confused about a homework problem set, feel free to come by office hours and ask questions. Okay. Or if you just want to say hi, then that's fine as well. I also have a Zoom option, and so if you can't make it in person for office hours, I do have a Zoom link. And so if you want to join via Zoom, then I do have that option available. Okay. And so the Zoom link for the office hours, as well as the lectures, are going to be on website, which we'll go over together. Okay, next are the course level learning objectives. And so, we went over the learning objectives earlier today. And so those are more kind of daily learning objectives. But I also have learning objectives that are going to be guiding the entire course as a whole. Okay, so this is mostly just to show you guys that I'm not just up here doing random stuff. There is a plan. There is an organization for the class. And so, what I'm hoping and my goal is by the end of the class, you should be able to do everything on this list. Right? So by the time Christmas comes around, you'll pull out that syllabus and look at the course level learning objectives. You should be able to do everything on this list. If you can't do everything on this list, then that was my fault. That was my fault. Not being able to cover it or teach it effectively enough for you to feel calm. Right? But for now, these learning objectives, may not mean much right now, but by the end of the class, I'm hoping they'll be able to. Okay, so let's talk deliverables. Okay. All right, so this class is mostly a project-based class. Okay. So there are going to be 7 homework assignments, and so among those 7 homework assignments, 6 of them will be ANSYS activities. Okay, so those will be basically assignments in ANSYS, where each of those assignments we're going to learn a new skill or a new feature within ANSYS, and then you go home and you practice it yourself, okay, and submit a report. There is one problem set that kind of has to do with the theory, and that'll be kind of the second half of the course. Okay. There's going to be one midterm project, and so halfway through the semester, you'll be able to apply ANSYS to a very simple case and write a technical report as if it was a finite element analysis. Okay, and you'll submit that for credit. And then there's one final project. And so the final project will be your chance to apply ANSYS to a subject of your choice. So I would say most people kind of apply ANSYS to their senior design projects, and this will be class here for seniors. But you can apply ANSYS to anything else. Okay, so all the homework's in this class just because this is an elective class, and so you guys all chose to be here. I didn't go to your house and force you to enroll in the class, right? And so I'm trusting that you guys all want to be here. So the homeworks will be graded on completion, and so I'm not going to go through and nitpick your homeworks. Okay, that's for the ANSYS activities and for the problem set. I will drop the lowest homework assignment as well, right? Just to give you, but please do them all. Okay, so every single assignment in this class kind of serves a purpose. Every single ANSYS activity teaches you a new skill or a new feature within ANSYS. And so if you don't do one, then you're kind of missing, part of your ANSYS learning. And the problem set is important for the midterm. Every assignment is important, But just to give you some flexibility, I would leave. Okay, so that third bullet point I think is a mistake. There's one midterm exam, so obviously it's not going to be cumulative. So the midterm exam is just going to cover stuff on the theory. The midterm project is only going to cover stuff on Kansas. Oh, there's no real overlap. Okay. And then these are the dates that I have planned for everything. So midterm project is going to be due right before Halloween. So midterm project is going to be due on Friday, October 28th. Midterm exam is going to be the last Thursday before Thanksgiving week. So that's Thursday, November 19th. Okay. And the final project will be due on Sunday, December 20th. So that's Sunday after finals. Okay. So that is kind of the latest that I can have the project due, just because I do want to have everything graded for Christmas. So I know you guys get busy during that time, but that's I can't really push that back any further. So that's plan to have your project done by then. Okay. All right. Any questions on the deliverables for the class? Yes.
So the midterm is like a written exam?
Yeah. So the midterm exam is going to be a written exam. It's going to be all calculated based on the theory. Okay, course grades. And so this is how the course grades are going to be broken down. So all the homework assignments together will be worth 10% of your grade. Midterm project will be worth 15% of your grade. Midterm exam will be worth 45% of your grade. So that's kind of like a pseudo final exam. And the final project will be worth 30%. Okay. Letter grades will be assigned. I think this is a pretty standard breakdown. So 90% and above are A's, 80% and above are B's. 70% above are C's, 60% above are D's. Okay. One thing I also do at the end of the semester is that I will scale grades. Okay, so what that means is that after all the grades are in, exams, assignments, projects, everything's graded. What I do is I look at the overall class average in terms of percentage. Okay, and if that average is lower than what I like for this class, then what I'll do is I'll add points to everyone's grade until we reach that threshold. Okay. So for this class, for an elective class, usually I'm a bit more lenient. I usually like the class average to be the B- area, so like 80, 81, 82. And so let's say at the end of everything, then the class average ends up being like 75. Then you can expect, maybe 5, 6, 7 points to be added for I assign that. Okay. But I will say that historically for finite elements, I would say generally people do really well on the projects. So most of the time the grades end up being like in that 80 10 range. So I don't think I've had to apply any kind of curve or scaling for the last few years. But that option is there in case I need. All right. Any questions on the grade breakdown for the class? Okay. Good. All right. Textbooks. So I have 2 of them listed for this class. Neither of them are required, and so one of them is going to be covering more of the theory side. So that is the Logan textbook. So that is a first course in finite element method. Very apt title because this is your first course in finite element. Okay. So the one that I just have personally is the 2006 version. Yes, I am getting old. I realize that tell me, but I know that there's probably a newer version of that textbook, so you can find that. Okay. And then the ANSYS side, we're going to be using a publication from STC. Which is finite element simulations with ANSYS Workbench. And the one that I have is 2020, but again, they write a new version every year. So feel free to pick up. Okay. But with that said, neither of them are required, and so it's not like you need them to do any of the activities. You don't need them to finish the problems. I pose the full problems on Canvas. Okay. But if you are looking for a good reference, okay. But I always tell people that, never pay full price for a textbook, right? Even though I am getting older, I still remember as a student how much money I had to pay for textbooks, and I'm still mad about it to this day. So you might be, and so my friends ask me all the time, come on, Justin, you're getting old, man. Like, you gotta let this stuff go. You can't be mad about stuff that happened 15. Like, no, I'm still mad. I hold grudges for a very long time. So let me give you an example. And I apologize for those of you that just came from the village, you're gonna hear the same story again. But when I was applying for grad school, there was a faculty at UCI that wanted to recruit me as part of his research. So he invited me to come to campus. So he invited me to come on a Saturday, just sicko, on a Saturday for whatever reason. And so we said, yeah, UCI, they don't check parking on the weekends, so you can park anywhere on campus. And so I do. I park in the most convenient parking structure next to his lab. And so I park there, I meet him, I meet the students. I said, this sounds kind of interesting. When I get back to my car, I find a $65 parking ticket from UCI parking enforcement that wasn't supposed to be working that day. Okay? And I'm still mad about it. And so, when I went home, I found out that this faculty that invited me to UCI, he wrote a textbook. And so first thing I did when I got home was I pirated his textbook. I downloaded it. So anyway, that was a completely unrelated story. But if you did want to pick up the textbook, for this class, don't pay full price. Be resourceful. Okay. Next is the course website, or Canvas. And so Canvas is the website that the university forces us to use. It's fine. It does everything that we need to. But basically any content that I produce for the class, whether it be lecture notes, lecture slides, ANSYS activities, solutions, study guides. I have a bunch of handouts on different features in ANSYS, and so I will tell you that I've done a lot of exploration in ANSYS, and we're not going to be able to cover everything. But I do have handouts for a lot of features that some of you may be interested in, like heat transfer, fluid mechanics. I know some of you are interested in ANSYS. Okay, so everything that I produce for the class will be on Canvas. So I don't hide anything from this. But everything I make will be available. Okay. All announcements will be made through Canvas as well, right? So I think everyone that's involved should be getting their emails. Okay. I always recommend check Canvas on a regular basis because I usually post things on the week. Okay, other course policies, and so everything here doesn't really fit into another category, so I just have it here on a slide here. Okay, so first being homeworks, and so homeworks for this class, they're graded on completion, and so don't feel pressure to kind of get everything correct. But I also accept late homeworks as well. Okay, so if you can't make a deadline, because I know you guys get really busy during the semester, don't feel bad about submitting homework late. I do accept them, but I do dock points, and so every day that a homework is late, I do dock 10% off of it. Okay. And at any time, if Canvas is down, and let's say another hacker group puts Canvas at ransom again, and Canvas is down, you can always scan your homework and which for this class, I know the majority of your assignments are going to be on ANSYS, so you can just send me the PDF. That's fine. Okay. I do prefer Canvas though, and so if Canvas is up, don't just use Canvas. I don't want to get 15 students turning in their assignments, but if for some reason Canvas isn't working, you can always. Okay. All right, regrades, and so this mostly applies for your projects and the exam, or the exam singular. And so, I do make mistakes in grading, so I'm not perfect. And so, if you ever feel like you want more points, or if you want to discuss things, I'm always open to discuss that. Just make sure you do that within a week, right? And so usually I'll try to grade things within a week after you do it. And so you have a week after that, after I return it to you, to request a regrade. Okay. And finally, emails, right? So emails are my preferred way for you guys to communicate with me. I know Canvas has its own kind of messaging feature within it. I hate it, but I also won't get mad at you if you message me on Canvas. But I do prefer that you have any questions. Okay. And if you are going to email me about the class, I do ask that you include EGME 410 in the subject line. Just because there's a lot of you guys, and I have a lot of other students. I just came from a fluids lecture with 50 people in it. So it just kind of helps organize my life. So I know that you're emailing. And usually I'm pretty good with emails. So I'll try to, I read all of them. I'll try to respond, within at least 2 days, except for weekends. I'm not going to email you. Sundays are for me to spend time with my own son. Any questions on these policies here? Okay. Okay. Next is graduate credit. So if you are a graduate student taking this course, then you need to do extra assignment. If you're in the blended program, or if you're thinking about switching to the blended program, you need to do the graduate assignments. If you're an undergrad and you're taking this and you want to take this for graduate credit as well, let's say you're taking extra technical electives, you need to do the graduate assignment. Okay, so please let me know ahead of time, just because this is a 400 level class, and so there is an extra assignment that you have to do. I am still thinking about what the graduate assignment will be. but I do need to get a list of everyone that needs to be. So you're going to be, if you're taking this for grad credit, you're part of the blended program for grad student, let me know as soon as possible just so I can get a list of people. Okay. And then finally, academic dishonesty. Okay, so I have a pretty zero tolerance policy for this. And so any act of academic dishonesty, and anything where you're not doing the work or you're submitting work that wasn't sent by you, I count that as academic dishonesty, right? And so that includes, copying off someone's work, using AI tools, paying someone to do an assignment, which I find crazy. All of that. And the reason I have a policy like this, it's simple. I think it's, I think people just kind of make this needlessly complicated. But I think the main reason is, you're in this class to learn at the end of the day. Okay. It would be one thing, if I'm assigning you guys these tasks, if I'm assigning you guys projects, if I'm going to take those projects and sell them and produce profit, yeah, at that point, then yeah, I don't care. Because for a situation like that, there's no benefit in you doing the project except for producing profit, right? But that's not why you take a class, right? In fact, you guys are paying money to be in this class, right? And so the whole point of taking a class is to gain knowledge and to gain skills that you can use to, market yourself and get other opportunities. And so if somebody else is doing your work or something else is doing your work for you, then it just ends up just being a waste of everybody's. And so, if you're using these tools, then, then there's really no point in taking it. Okay? But I always make this promise to students. Okay. So my job here, my role as your instructor is not just to be a gatekeeper, not here just to judge you or grade you. My primary job here is to help you guys succeed. Okay. So I promise you that, if you ever feel like you're struggling, if you ever feel like you're falling behind and you don't understand something, come to me for help. And I promise you, I will do everything I can. Okay. Whether it be just extra office hours or making a plan, or maybe you just need some flexibility for the deadlines or the assignments. I'm willing to work with you. But you have to reach out to me. Because if you kind of open that Pandora's box of using ChatGPT and you may not believe so, but it is actually very easy to tell when people use it. There's not much I can do with that. But I'm here for you guys, right? And especially for an elective, right? Like I said, you guys chose to be here. You guys chose to be in this class. And so I want to make sure that you guys get everything that this is. An elective is not something you just check off. You're in this class because you want to get something out. And I want to make sure that you get the skills and knowledge that fit. Okay. And so before we take a tour of the Canvas site, I do want to talk about the first assignment, although it's not really an assignment, but it's just simply to send me an email, okay? So I do this for all my classes every semester. I've done this ever since I started working here. It's one of my favorite parts of the semester, right? So we're going to be spending the next 16 weeks together. It's basically now until Christmas. So, if you count the number of days between now and Christmas, that's a lot of days. And so, it's a lot of time to be stuck with someone and to not really know who they are, right? And so, I always love to get to know you guys, right? So you guys will just naturally get to know me just because, I'm up here talking for 75 minutes twice a week, every week. So you'll get to learn about my personal life, my son, friends, my pets, right? So I just like to talk about this stuff, but this is kind of your only chance for me to learn about you guys, okay? You can send me an email and you can feel free to, share as much or as little as you want. I have these questions here. Some people take it literally that I want you guys to answer these questions, and it's like an interview with a gun pointed at you. Right. So these questions are just there just to help guide your introduction. So feel free to answer these questions if they help. But you can talk about anything that you want. I've had people just send me an email that just rant about their pets, and that's really cool, right? I've had people send me pictures of their pets. So I have 2 cats, and so I love my cats. And so if you send me pictures of your pets, I think that's the best way. So just send me an email. You can talk about as much or as little as you want. You can just send me an email and say, I don't want to talk to you. I don't want to get to know you. All right, cool. I'll give you full credit. Okay. So it's not something I'm forcing you guys to do, but I think it's nice to do, get. Okay. The due date for this is this Friday by 11:59 p.m. So please make sure you send me that email. And just like all emails, just make sure you include EGME 410 in the subject. Okay. All right, it's hard to talk when you're sweating up here. It's freaking hot. Any questions on any of this? Okay, all right. So I think last thing we'll do today, just because I am close to dying, I'm maybe like 10% to dying. We'll go through the course website, and I think we'll call it a bit early. Just pray that the AC works on Thursday. Okay. All right. Okay, so this is the course website. So probably a lot of you have seen it already. I think I sent them link in an email to everyone, yesterday. But I try to keep things simple. Right? I know, Canvas comes with a lot of bloatware. There's really different apps that you can have activated here. I trust me when I say I disable like 95% of it because they all are useless. But so I try to keep things to just the essentials. Okay. So when you first access the course website, this is the page that greets you. So it is EGME 410, Introduction to Finite Element Method. That's me. If you click on this, you'll see my Tinder teaching profile. Click on me. Right. Class times Tuesday, Thursdays, 5:30 to 6:45. Location is CS 304. Okay, so all of you know that because all of you are here. It would be weird if you somehow stumbled upon this and you didn't know what time this was. Okay. Course description. This is what I have written in the syllabus, and so you can read that here. Okay. Here are the course level learning objectives. Here is the syllabus itself. Okay, so this is just the text version. So we just went over everything in the syllabus here, but definitely you can look at it yourself. Okay. Zoom links, and so here I have the Zoom links for the lecture and the office hours. Okay. Oh, I forgot to mention them. So and some people have figured this out already. But I do stream these lectures on Zoom every day. I do record them. I do post the recordings on YouTube after for you guys to view. But that also means that if you feel more comfortable kind of attending the lectures on Zoom, you are welcome. Okay. There's only one day that I require you guys to be here in person, and that is on the exam day. But for every other day, you are free to attend the class on. Okay. Especially when the weather's like this, and probably the AC is working at your home better than it's here. Maybe you can attend. Okay. I will say that on the days that we do the ANSYS activities, it is a bit easier for you guys to work here in person. Okay. Because what ends up happening is that I do write out all the instructions for the ANSYS activities, but people run into snags at different points, and so it is a lot easier for me to go around and help you guys if you guys are here in person. Okay. But with that said, even for the activities, you guys aren't required to be here. It's just a little bit harder for me to help you guys over. Questions?
ANSYS activities are for.
It depends on the week. So our first ANSYS activity next would be Tuesday. I think most other activities are going to be on Thursday. Yeah, but it'll change. Okay, but if you want to attend the lectures on Zoom, that's that. And then the office hour links are here. All right, but probably the most important part of the homepage is the course outline. So you can see here I have a week by week breakdown in terms of all the topics that we're going to cover in this class. Okay. Right now, most of it is, not clickable just because, we're only in week 1. But as we go through the semester, each of these links here become clickable. Okay. For instance, so if you click on week 1, you'll see here that I have what I call the weekly pages. And so here I have this outline of the week. Okay. And so there's a little word here in terms of what we're going to be learning that week. There are the learning objectives for the week. We have the recording lectures, and so after I post the lecture recordings onto YouTube, the links for that will be here as well. Okay? So I'm not going to be corny and force you guys to subscribe to my YouTube channel. Not like I get ad revenue anyway. I think my videos 10 or 20. And so if you ever need to access the lecture recordings, they're here on the campus site. Okay. All the assignments will be here as well, and so anything that's due for that week or anything that's due soon. You can find that for the weekly page, and any files that you need for the week here as well. Lecture notes, lecture slides, homework solutions, homework assignments, that will be here for you. Okay. So usually I try to get the weekly page up, probably on the Friday before the week, right? So the weekly page for week 2 will be up by this Friday. And so I always recommend you guys to check that weekly page, download any files that you need, be aware of any deadlines that are coming up, right? It's just a good way to kind of move forward. Okay. So I kind of really organize this class kind of week by week. Okay. So it's hopefully you guys kind of settle into a rhythm, checking the weekly page, checking the lecture recordings, things like that. All right, so next page right here is the announcements page. And so I think for the most part, you probably won't have much reason to come here because all of the announcements that I will email directly to you guys. But I do have to activate this tab here just so I can send announcements. But if for some reason you wanted to look at all the announcements in class, this is the page to do it. Okay. Usually I try not to spam you guys because you guys honestly get enough junk from the university about just whatever random event you're showing one and two time, at the library. So I try not to spam you guys with emails, and so but when I do send emails, it's through this campus announcements tab. Okay, assignments, and so any assignments that I assign here will be on this tab here. So all of the ANSYS activities, we can access them here. Any ANSYS any files or CAD files that we need, any PDFs that need ANSYS activities or problem sets will be accessible here as well. Okay, you can check when the activities are due. Okay, so definitely pay attention to these. All right, so right now there's only one assignment, which is just introductions. But as we go through the semester, more and more assignments will be added. All right, next page here is the grades tab, and so this is where you can check your grades. And so generally I am pretty on top of grading things. So usually within a week, I'll grade whatever you guys turn in. So whether it be an activity, homework assignment, project, exam, usually I'll get back to you within about a week, right? And so usually at any given time you can check this page to see how you're doing. Okay? It's not my style to wait until the end of the semester to grade everything, which to me is lunacy. I don't know why you subject yourself to that torture. It's like doing your dishes, right? It's better to do your dishes as you go. Don't wait until the end of the month to do your dishes. That's disgusting, right? So, I don't wait until the end of the event to grade stuff. I grade stuff. You can check this tab here to kind of see how you can see the grading weights here on the All right, next tab is people. So this is a list of everyone that's in the class, and there are a lot of you in the class. Okay, so I think there's about 50 people here. 50. Yeah. All right, next is pages, and so you probably won't have any reason to come. I'll probably disable that. This is kind of where I make the pages. Next is files, and so this is where you can find any files related to the course. So if you're following week by week, you probably don't have any reason to come here because any files that I post will be posted on the weekly pages. But if you're looking for a very specific file, let's say you're looking for a very specific lecture notes or looking for homework solutions, you can find them here. Okay. So all the ANSYS files that we need for the activities actually have them posted already. I don't have the assignments posted yet, but the files are there. All the lecture notes are here as well. So for some reason you want to read ahead, lecture notes, you can find them here. But the final project, there's nothing here yet. Midterm project, nothing here yet, but those will be populated once we get to that point in the semester. Okay. Any solutions will be here as well. Next tab here is the SOQ tab, and so this is not available yet. So you have to wait until the end of the semester to give me a 1-star review. Right? You can do that right now. But I think this should be activated probably around week 15, week 16. Okay. And then this tab here is student resources. This is something new. So this is actually something useful because campus actually has a lot of resources that are available to you guys as students that honestly not a lot of people take advantage of. So things like the academic integrity policy, things like CAPS, and so if you need mental health support, Title IX, all the Office of Civil Rights and Equity, the accommodations, DSS is here. And also things that I have no idea what they do, like you at Cal State Fullerton, I have no idea what that does. But it sounds good. And then Compass at Cal State at Fullerton, no idea, but probably sounds useful as well. So if you ever need any campus resources, you can find them. Okay. All right, and so that is a tour of the Canvas site. Any questions about anything we covered today, syllabus, Canvas, course at all? Okay, all right, so that's we'll call it here as just about an hour. So when we come back on Thursday, we'll have our first lecture, and then next Tuesday we'll have our first ANSYS sessions. Okay. Thank you guys for coming today. I hope you guys have a good rest of your evening. Stay cool, stay hydrated. I definitely need to drink water and I'll see you guys all on Thursday. Let's go. Bye.
Yes, Gussie?
Huh?
Yes, Gussie.
Sometimes I don't know.
So, I know, at least it's like there was a classes, I mean, responses.
I think right now.
Fifty days max, and we're at 48. I'm in third place.
You're sure.
Okay.
Okay.
No, they shut down.
Oh, really?
Like right around the time finals came around. They got shut down. I found a new job. Defense, aerospace defense.
Yes.
Yeah, down in Parker, aerospace.
Way too hot.
I'm not trying to get a.
I was talking to come on.
Someone, someone like Barry, like, shine.
That's
So it's like sprinklers and. It's like sprinklers and. I don't know about fucking anything. So I have an interview at the. Another machine.
Yeah, they do. My IT was supposed to have.
the class right now.
Tomorrow. Good looking at his. Yeah.
Yeah, so I think Dr. James. Can tell you about it. Back to what you were sending, you want to so I didn't. So I can send it. Nice. And then 540 is the next one.
Yeah, they said like, oh, we don't have an active, you know, like two back, like, my.
540 is advanced.
Saturday for. I mean, I'll have to dive, see if I like it.
It's just the name of the product. So I think it has some, it's an acronym for something. I think the system, something.
Started yesterday, this one.
Oh, I always forget. Let me remind me on Thursday. I'll show you guys how to download. Actually, if you just search Ansys, download that. On No, it's offered just straight from now. Yeah. Yeah.
So this project, like, maybe.
Yeah, so I'm gonna see, so I'm gonna see, sometimes I come to the squares, I think like it sucks. Sometimes people drop it.
I mean, it's got AC in their blue blocks.
So I'll be. Same thing I told everyone, I'm gonna cap things. I can't.
So we'll see what it is,
You know, if it's not in class by the end of the week, I would. Probably start looking at classes to see.
I got like.
Because, you know, yeah, if everyone sticks on class, then.
Pull over and like see if I like it. If I don't, I don't know, that's just like. Yeah.
If you're gonna be doing the.
Yeah, no problem.
I don't know.
So that's the blended BSM, so if you're gonna go for your master,
Yeah,
but if you're not gonna go for your masters, then you don't have.
I don't get a job.
I just have.
Yeah.
Okay. Yeah, so I'm capping the class at
You're like 7
I
years.
think right now there's like 14.
Yeah.
So sometimes people drop, so you can stay on the wait list for the next couple of days and see if things improve, but I'm gonna put on one cap. So if you're not one of the 50 people in the class in a couple of days. Yeah, you can come at least for Thursday, but I would say, you know, it's. Next week, probably.
Started with.
Yeah.
And it goes for two of that.
John.
No, so right now it's hard to kind of say. Because
I didn't want to take like 15.
No paper exam, no.
So I did like 3 academic, cancer here.
Yeah.
Yeah. Yeah.
I'm done here, that's what.
Yeah, no, like they showed me like the time.
It's tough, so I know there's a wait list for the class, you know, I'm telling you, I'm capping it at 50 students, and so, you know.
You see, who said like 2 C++ class.
I'll ask some part number, ask it if it be. So, if it doesn't. look like-
I'm not doing poorly, bro. I knew exactly how to do it. Yeah, just like different syntax. Like, that's what you got in now. Yeah, that's what you do.
Right now, it would only be the top, if everyone stays on, but sometimes people come to this class, I don't wanna take you. So, there may be people that don't. Yeah. Mhm.